Yes, so hi everyone. So welcome to Easy Tech Masters online series. And today, we'll discuss about the construction of the transformer. Construction of the transformer, as we'll see. Construction of transformer. Yes, construction of transformer. So, what is the definition of transformer before going to the construction? It is a static electrical machine that can transform electrical energy from one level to another level without changing frequency. And what are the major parts in the transformer? You see, major parts. Yeah, from the definition itself, it says that there is no rotating parts in the transformer. No rotating parts in the sense the other parts are the windings may be there, and second one is the core is different. Core is also major part. Core and windings. Core and windings. So first let us see what is core. Yeah, here in the case of transformer, the core is laminated. Core is laminated. Yes, why we laminate the core in the sense to reduce the eddy current loss. To reduce eddy current loss. To reduce eddy current loss, transformer core is laminated. Yes, laminated with which material? The transformer core is laminated with silicon. Silicon, and or you can also say sheet steel. Sheet steel. So which is having the silicon of 4%. Sheet steel which is having the silicon of 4%. And these laminations, there are various shapes of the lamination. What are the various shapes of laminations in the sense? The laminated shape may be like this. This is I shape. That's what is this shape? I shape. And next one is L shape. And next one is U shape. And next one is E shape. Yes, what are the various shapes of the laminations? That is I shape lamination, L shape lamination, U shape lamination, and E shape lamination. Yeah, and to construct the core, what are the various facilities we have in the sense? We have the two types of facility. That is, you can construct the transformer core like this, or you can also construct the transformer core like this. This kind of construction is called core type transformer. Core type transformer, and this kind of construction is called shell type transformer. Core type transformer and shell type transformer. Now the question is, sir, how we can construct the core type transformer with this laminations in the sense? This is very simple. That is, first one, with I-shape laminations. I-shape laminations. Yes, with I-shaped laminations in the sense, like this. That means we may require 4 I-shaped lamination. Like this. This is one I, this is another I. That means you need 4 joints. Here you need one joint. Next here you need another joint, 3 and 4, like this. 4 kinds of joint. The 4 joints are required. Therefore, the core type of transformer which is made up of I-shaped laminations is not at all, yes, this not at all suggestible. Okay, and next, second thing is you can construct the transformer core with L shape also, L shape lamination. L shape lamination, like this. The two L shape laminations, by using the two L-shaped laminations, you can construct the core in this fashion. So here, how many joints you require? 1, 2. That means you can reduce the L-shaped joints. You can reduce the joint. In the previous case, you need the 4 joints, but here you need only 2 joints. Okay, and the vertical portion on which the coil is wound is called limb of the core. That is, here you can wound the winding. This is called the limb. That is called the limb. Thus, whereas the top and bottom horizontal portions are called yoke. Top and bottom, these two are called yoke. Yeah, these two are called yoke. And this is how we can construct core type of transformer. And what do you mean by shell type of transformer? In the sense, it is very simple. You can construct the shell type of transformer with E type lamination and I type lamination, like this. By using this, we may have the shell type transformer. Okay. And here you can place the windings this central limb. If it is primary, then this may be secondary. Why? Because here, if you say, the flux may be like this. The flux which is in the central limb is not same in the side limbs. So therefore, according to the definition of transformer, the flux in the primary winding should be same as the secondary winding. So hence you can say the two windings may be placed at the central limb, like this. Okay, yeah, this is how we may have the uh, transformer cores. And windings in the sense, it is the conducting material to wind the transformer. Yes, generally, which kind of material we use? Yes, which kind of winding, which kind of material we use? That is conducting materials only. And these windings surrounded the core. The coils used are wound and are of cylindrical type, having the general form circular, oval, or rectangular. That means these windings maybe like this, okay, and maybe in this fashion, rectangular or oval type. And moreover, these windings also classified as HV winding as well as LV winding. HV winding stands for high voltage winding, and LV winding is low voltage winding. Low voltage winding. Generally, LV winding is placed nearer to the core. That means if you see, this is the core of the transformer. This is the core. So here it may be, this is LV winding. This may be HV winding. LV winding. This is also LV. And this will be HV winding. Okay. So what is the conclusion of the construction? In the construction, you can see the major parts in the transformer are transformer core and winding. And the transformer core is laminated to reduce the eddy current loss. Transformer core is laminated to reduce the eddy current loss. And we use high grade silicon steel material. And to reduce the hysteresis loss as well as the eddy current loss. Okay, high grade silicon material is used to reduce the hysteresis loss, and laminated is laminated to reduce the eddy current loss. Okay, and we have the laminations, various types of laminations, that is I-shaped lamination, U-shaped lamination, and E-shaped laminations like this. And based on the placing of the laminations, we have the two types of constructions. Those are core type transformer and shell type transformer like this. Yes, what is core type transformer? In the sense, we have seen the core type transformer, how the winding is placed, and how you can construct the core type transformer with the help of I-shaped laminations and the L-shaped laminations. Okay, and one more point I want to tell you, that is, in the transformer is not the meaning of one, that is one layer of the L shape. One layer of the yeah, so only one layer of the L shapes are not present in the transformer. There may be n number of layers will be there. This is layer 1, layer 2, layer 3, layer 4, layer 5, so on like this. Suppose for example, if I have the n number of layers are there, and you can see that here you have the one joint, and here also one joint is there. Next layer also the same place we have the joint, same place we have the joint. Next layer also we have the same place joints you have. And if the joints are distributed continuously, or if the joints are placed continuously, then there is the chance of the leakage of the flux. The flux leakage will be increased, which cause to increase the losses in the mission. So whenever the magnetic losses or flux leakage is increased, obviously the performance is decreased. In order to avoid that, in order to avoid this one, or in order to decrease the reluctance of the core, reluctance in the sense, it is the property of the material to oppose the distribution of the magnetic flux. And due to this continuous uh, continuous joints, so the leakage flux may be increased due to the increasing in the reluctance. In order to reduce the reluctance, what we do in the sense, this is for layer 1, 3, 5, 7, 9, like this. And how we can do in the sense, how we can do for 2, 4, 6, 8, it will be reverse. Reverse in the sense, yeah, reverse in the sense like this. This is 1L and this is another L. This is another L. Okay, so this process, so if you do like this, one layer you have the joint here, another layer you have the joint here. That means the joints are displaced from one layer to another level. This scheme is called the staggering. Yes, what is this one? This kind of thing is called the staggering. What is the benefit of the staggering? You can reduce the magnetic reluctance. Therefore, we can reduce the, yes, what you can reduce flux leakage, and you can make the uniform flux distribution in the core, and moreover you can reduce the magnetic losses, and finally you can improve the performance of the transformer only because of this staggering. Okay, yes, thank you for watching this. Keep watching these videos. Don't forget to subscribe this channel, and please press the bell button to get the notifications from this channel. Yes, thank you.